Welcome to the general power rule. It is a very important derivative formula. You're going to use it a ton and get very good at it. Basically, whenever you have an x to any power, to derive it, you take whatever the power is, you put it out front, and then you drop the power by 1. You'll get very, very familiar with this one. So, see right here, you're going to take that 4, put it in front, drop the power by 1. You'll see in a little bit. Okay, can we use this tons? Very useful. Now, the thing is, this is a little bit more complicated problem. If it was just one problem, like cover this up, bam, well, just make the 4 out front, it'd be really short. But I did several things here, and just to show you different variations in one problem. So, the first thing you want to do when you're doing derivatives is to change all roots to fractional powers. See this root? I'm going to change that to a fractional power. If you don't, it makes it really difficult to take a derivative, because I want a fractional power, a power that's a number or a fraction. Okay, next, you want to change all exponents in the denominator to negative powers. You don't want to leave denominators with powers. You want to bring it up and make them negative. So both those things will really help you, because then you can use the power rule to it, which is a very powerful tool. So before we even derive this, take the derivative of it, we need to change the way it looks. It'll make it a whole lot easier for us to do this. So let's change it. What we got here is this will be, okay, f of x equals, I'm not going to change that one. That one's pretty snazzy. I'm going to change this one. Well, you have to realize that x to the second root, called the square root, there's really a 2 right here. Hopefully you realize there's really a 2 right there and there's a 1 there. This is called x to the 1/2 power. All right, the way I remember that, by the way, my roots are always out here. And if you think about it, if you think of the two numbers, aren't roots kind of like at the bottom of a tree or bottom of plants? Aren't the roots always going to be the bottom and the other numbers the numerator? That's a kind of cool way. Then the roots are at the bottom and the other numbers the numerator. Okay, anyways, so the square root of x is x to the 1/2. And I'm going to rewrite this one. You gotta kind of be careful here. I'm going to leave the 4 on top. What's 2x to the third times, what's 2x times 2x times 2x? So this is saying, or basically, aren't we cubing both of these? So 2 cubed and x cubed. So if we realize that's going to be 8x cubed. All right, I now changed it a little bit. Okay, I got all the roots to fractional powers, but what I did not do is I didn't do the second one. I didn't put all the denominators to negative powers. So let's keep going. All right, here we go. I have 3x to the 4th minus x to the 1/2. And I'm going to change, can I reduce this, by the way? 4/8. Isn't that 1/2? And isn't this, can I bring that up and make that x to the negative 3rd power? Yes, I can. Okay, now I'm in all nice, easy form that look like the power rule form, and I'm going to derive each of these one by one. So watch this. I am going to derive it, so I put a little mark right there. That means derivative, very common notation. And so what I'm going to do is I'm going to leave the 3 out front. You can take any coefficients, you can let them just sit there, and I'm going to derive just this. So when I derive this, all right, the 4 goes out front, remember? The n goes out front, and you drop the power by 1. So the 4 goes out front, x, and I drop the power by 1. So that'd be 3rd. Okay, I derive that piece. Next, I have the minus. Take the 1/2, bring it out front, x, and I drop this by 1. So what's 1/2 minus 1? Yes, negative 1/2. Okay, next, all right, leave the 1/2 out front, at the positive 1/2 out front. And, okay, bring the negative 3 out front would be negative 3x. Drop the power by 1. Be careful with that. It's negative 3 minus 1, not negative 2. It's negative 4. Yes, it's so easy to mess that one up. Remember, when you drop it by 1, you minus 1, it's negative 4. Be very, very careful. It's so easy to miss that one. All right, this is all ugly, so now we got to simplify it. Let's see what we get here. we get f prime, or the derivative of f. We multiply these two, so it'd be 12, x to the third. All right, negative power, we don't like negative power, so we're going to move it back to the bottom. So I'm going to make this 1 over 2, x to the 1/2. Just don't like negative power, so I'll bring it back down. And then here, well, can I do negative 3 times 1? Would that be a negative then? And would that be a 3? Isn't x to the negative 4th, is this negative power also going to go to the bottom? I have the 2 right there. So wouldn't that go to the bottom, leaving you x to the 4th down there? Hey, guess what? That right there is the derivative. Now, you could change this to make it look prettier. For instance, you could get all the denominators to be the same. Get common denominators, which is very common. This one's going to be a little ugly to do that, but we're not going to worry about getting the common denominators for this problem. But it is very important in future problems to get a common denominator when we deal with derivatives. All right. Some teachers would let you have negative powers. I tend to make them all positive powers in the end. All right. There's different ways to simplify in calculus. Some teachers, some situations are pickier than others in how you simplify. All right, but the key again with deriving is you first want to do these two things. All roots into fractional powers and all exponents in the denominator to be negative. You want to make them a nice simple power so you can use the power rule, which is very quick and easy. All coefficients just kind of stay to the side and then multiply it by them in the end. Now, a lot of people actually skip this blue step. They go straight from here, boom, 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 with practice. I just showed it because we're kind of teaching you how to do it right now. So, and a lot of times the problems are a lot simpler than this. This is just I try to use multiple things going on. Now, one thing I didn't mention in the beginning, which you really need to realize, and you probably should know this already, that when you derive or take the derivative of stuff, when there's a plus or minus, you basically do each one individually. Think of them as your own problem individually. If you have plus or minuses between, you are allowed to do that. Derive each one by one. So that's important to think about them each almost as their own individual derivative going on. Hopefully this helps. Good luck with your derivatives, and the power rule, you're going to see it so much throughout calculus. Good luck.